Yes, let us come back and do the 2017 paper. So 2017, I think this is a part A part, and we are left with one more question of part A, and then we have the part B. So with that, we'll be completing all the 10 years board papers. Please do practice it once you're completing the chapter. Practice with the board papers. Then it'll be easy for you to remember the reactions, and you also know the pattern how to solve it in the board exam. So let us see. So here, last year they've given this question. What did they do? They've clubbed both aldehydes and amines chapter. So how are we supposed to do this? Let us see. Now basically you have your acids. I have shown one reaction of acids with ammonia. I said the reaction is very important. This is the main reason, because from the acids we gradually convert them into amides. From amides we go converting into amines. From amines we'll be converting into isocyanides also. Let us see. First you're going to take this acetic acid. Whenever you're taking acetic acid and add ammonia to this, I said first it's going to form an ammonium salt, that is ammonium acetate. This whole thing gets added to this hydrogen. What do we get? I get ammonium acetate. Now this is not the final product. After this, when you're heating this particular compound, two hydrogens from here and one oxygen from here escapes as water. What do you get? You get a compound CH3CONH2. Now this is your amide. This is your acetamide. That is your reactant A. So you're going to write this as reactant A. Observe. Now what they say? They've taken this reactant A and they allowed it to undergo reaction in the presence of bromine and KOH. Whenever you see bromine and KOH or bromine and NaOH, that is called Hofmann bromide reaction. Bromine, usage of bromine in the presence of a base, that is Hofmann bromide reaction, which I'll be doing in amines chapter. So what does that do? This Hofmann bromide reaction, so please write it here, Hofmann bromide reaction. So Hofmann bromide reaction converts amides to amines. Which amines? It's going to convert into primary amines. So this is your part B. Done. Now what did they do? They have again taken this primary amine. They allowed it to react with chloroform and alcoholic KOH. Okay, this is very important. Not aqueous KOH, it is alcoholic KOH. So whenever you're treating this particular thing, chloroform, and in the presence of alcoholic KOH, this reaction is called carbylamine reaction. Carbylamine reaction. Please remember, this is also there in amines, which I'll be doing. Carbylamine reaction, in the presence of KOH, always the amines get converted to isocyanides, offensive smelling compounds. So this is called methyl isocyanide. Yes, methyl isocyanide plus the leftover KCl and water is out. So this is what is the reaction. Now observe, I am writing the products finally. Now let me erase this and use the board. Now, compound A, what did I get? I got CH3CONH2. Done. Let me erase this part. This is over. After that, this was treated with Hofmann bromide reaction, KOH. What did I get? I got primary amine. This is also done. Then I have treated with chloroform and KOH, CHCl3 and alcoholic KOH. What do I get? I get isocyanide plus KCl plus water. This is your carbylamine. Let us write, this is your carbylamine reaction where you get isocyanides. This is your Hofmann's bromide reaction where you get bromide reaction where you get primary amine. This is your just addition of, this is done. Now let us write this compound. Now in this compound, what did they give? This is again a nucleophilic addition reaction. So when HCN reacts with this compound, what is this compound? This is a cyclo group. Which cyclo? Hex. So cyclohexanone. Fine. So this is a ketone. So first there is a cleavage here, minus, this bond shifts here and you get minus. What do you get? You get a compound like this. At this particular point, CN adds and your OH also adds. This is your compound, addition of HCN. So what is this? What is the name of the compound? Let me start like this. Cyclo, correct? So which hexone? Cyclohexa or hexanone. In this, what do you get? What did you get? Cyclohexane, cyanohydrin. So write down cyclohexane, cyanohydrin. That's it. Now next reaction is a decarboxylation reaction. We are using soda lime. As soon as you see the salt, just pick up Na2CO3. Yes, and this bond goes and shifts here. So you get Na2CO3. What did I say? What is the role of calcium oxide? Calcium oxide tries to keep, because sodium hydroxide is very hygroscopic in nature, so it tries to keep sodium hydroxide dry. It maintains the dry conditions in that particular reaction. So sodium carbonate is out and this hydrogen shifts to this benzene. You get a benzene compound. That's it. And please name this. Done. And again the same dibal. Whenever you see dibal, what did I say? The only role of dibal is to convert the cyano group to aldehyde group. Yes or no? So you have already got a cyano group. Try to convert this cyano into your aldehyde. Nothing to do. Copy the same. 1, 2, 3. So 1, 2, 3. You still have a double bond. Write the double bond. You have your CH3 and your CH. And the last is again, yes, CH and your CHO. Cyano only will get converted to aldehyde group. Yes, so how many is this? 1, 2, 3, 4. So 2 but or but2-enol. But2-enol. Why did I write but2-enol? But 4 carbon chain. En is in the second position. Alkene. Al is for the aldehyde. So let us come back and do the part B of this question.